Good day, everyone. Today on part 221, we'll be looking at sample and sampling techniques. At the end of this discussion, you should be able to explain the concept of population, concept of sample, and the various sampling techniques. You also should be able to discuss planning and decision making. Population and sample. The entire set of relevant units of analysis or data is referred to as the population. When the data serving as the basis for generalization is comprised of a subset of the population, that subset is called a sample rather. So a sample is said to be a subset of the entire population. For example, there are students in different departments in Nasarawa State University, but when our study population is the sample, we could take the students only from public administration department. They are only a subset of the entire population of students in Nasarawa State University. A particular value of the population, such as the mean income or the level of formal education, is called a parameter. Its counterpart in the sample is termed a statistic. So when you have variables you are considering when dealing with the entire population, you refer to those segments as parameters. But in the case of a sample, which is only a subset of the entire population, the segments or the variables considered in a sample are referred to as a statistic. The major objective of sampling theory is to provide accurate estimates of unknown values of the parameters from sample statistics that can be easily calculated. Moving on to the sample frame. Once researchers have defined the population, they draw a sample that adequately represents that population. That's one of the very important characteristics of a sample. Your sample must be able to represent the population, even though it's not the entire population, but it should be able to give a good information of what the entire population might be like. The actual procedures involved in selecting a sample from a sample frame comprises of a complete listing of sampling units. Ideally, the sampling frame should include all the sampling units in the population. In practice, a physical list rarely exists. Researchers usually compile a substitute list, and they should ensure that there is a high degree of correspondence between the sampling frame and the sampling population. The accuracy of a sample depends first and foremost on the sampling frame. A sampling unit is a single member of the sampling population, e.g., a household. The sampling frame is referred to as a sampling unit. A single member of a sampling population is referred to as a sampling unit. I beg your pardon. Usually, sampling units have numerous attributes, one or more of which are relevant to the research problem. The major attribute is that it must possess the typical characteristics of the study population. A sampling unit might not necessarily be um, an individual person. It could be an event, it could be a university, it could be a city, it could be a nation. The accuracy of a sample depends on the sampling frame, like I said earlier. Indeed, every aspect of the sample design, the population covered, the stages of sampling, the actual selection process are influenced by the sampling frame. Prior to selecting a sample, the researcher has to evaluate the sampling frame for potential problems. Sample design. The essential requirement for any sample is that it should be a representative of the population from which it is drawn. And this is so if it, the analysis made using the researcher's sampling units produces results similar to those that will be obtained if the entire population was considered. We have probability and non-probability sampling. In modern sampling theory, a basic distinction is made between probability and non-probability sampling. The distinguishing characteristics of probability sampling is that for each sampling unit of the population, you can specify the probability that the unit will be included in the sample. In the simplest case, all the units have the same probability of being included in the sample. In non-probability sampling, there is no assurance that every unit has same chance of being included. A well-designed sample ensures that if a study were to be repeated on a number of different samples drawn from a given population, the findings from each sample will not differ from the population parameters by more than a specified amount. A probability sample design makes it possible for researchers to estimate the extent to which the findings based on one sample are likely to differ from what they would have found by studying the entire population. When a researcher is using a probability sample design, it is possible for him or her to estimate the population's parameter on the basis of the sample statistics calculated. Non-probability sample designs. Three major designs utilizing non-probability samples have been employed by social scientists: convenience samples, purposive samples and quota samples. In convenient samples, researchers obtain a convenient sample by selecting whatever sampling units are conveniently available. For instance, a university professor may select students in a class, or a researcher may take the first 200 people encountered on the streets who are willing to be interviewed. Those are examples of convenience samples. Purposive sample are sometimes referred to as judgment samples. In this case, the researchers select sampling units subjectively in an attempt to obtain a sample that appears to be a representative of the population. In other words, the chance that a particular sampling unit will be selected for the sample depends on the subjective judgment of the researcher. Sometimes the main reason for selecting a unit in purposive sampling is the possession of predetermined characteristics, which may be different from that of the main population. For example, a study that demands for the preference of cigarette brands in a city. The researcher will need to select smokers purposively. You can't go around asking people who do not smoke about brands of cigarettes. They might not have any information. So your target population has to be predetermined. Quota samplings. The chief aim of quota sample is to select a sample that is as similar as possible to the sampling population. For example, if it is known that the population has equal number of males and females, the researcher selects an equal number of males and females in the sample rather than selecting more males than female or vice versa. In quota sampling, interviewers are assigned quota groups characterized by specific variables such as gender, age, place of residence, ethnicity are put into consideration. Probability sample designs. Four common designs of probability samples are simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Starting with the simple random sampling is the basic probability sampling design that is incorporated into all the more elaborate probability sample designs. Simple random sampling is a procedure that gives each of the total sampling units of the population an equal and non-zero probability of being selected. For example, when you toss a coin, the probability that you will get a head or a tail is equal. The probability is 50%. The random selection procedure ensures that every sampling unit of the population has an equal and known probability of being included in the sample. This probability is the sample population over the entire population. That's the small letter n over the capital letter N. The small n stands for the size of the sample, and the capital N is the size of the population. For example, if we are interested in selecting 60 households from a population of 300 houses using simple random sampling, from this information, you could tell that our N, our big N is 300. That's the size of the population. And our small n is 60, which is the size of the sample. Using simple random sampling, the probability of a particular household being selected is given as small n over big N, which is 60 over 300. And dividing that, you get 1 over 5 as the probability of a particular household being selected. Systematic sampling. It consists of selecting every kth sampling unit of the population after the first sampling unit is selected at random from the total sampling unit. Thus, if you wish to select a sample of 100 persons from a total population of 10,000, you will take every 100th individual. That's K will be equal to the population size over the intended sample size. And in this case, our population size is 10,000, and taking every 100th individual will mean dividing 10,000 by 100, which gives 100. Suppose that the 14th person were selected. The sample would then consist of individuals numbered 14, 114, 214, 314, 414, and so on. Systematic sampling is more convenient than simple random sampling. Systematic samples are also more amenable for use with very large populations or when large samples are to be selected. Stratified sampling. Researchers use this method primarily to ensure that different groups of population are adequately represented in the sample. This is to increase their level of accuracy when estimating parameters. The underlying idea in stratified sampling is to use available information on the population to divide into groups such that the elements within each group are more alike than the other elements of the whole population. That is, you create a set of similar or homogeneous samples based on the samples you are interested in studying. If a series of homogeneous groups can be sampled in such a way, when the samples are combined, they constitute a sample of a more heterogeneous population, and this will increase the accuracy of your parameter estimates. We also have cluster sampling. This is frequently used in large-scale studies because it is the least expensive sample design. Cluster samples involves first selecting large groupings called clusters and then selecting the sampling units from each cluster. The clusters are selected by simple random sample or stratified sampling, depending on the research problem. Researchers can include all the sampling units in these clusters in the sample or make a selection within the clusters using simple random sampling or stratified sampling procedures. Sample size. A sample, as we said earlier, is any subset of sampling units from a population. A subset is any combination of sampling units that does not include the entire set of sampling units that has been defined as the population. A sample may include only one sampling unit or any number in between. There are several misconceptions about the necessary size of a sample. One is that the sample size must be of a certain proportion, often set as 5% of the population. Another is that the sample should be total to amount to about 2,000. Still, this is Still, another is that any increase in the sample size will increase the precision of the results. These are faculty notions, by the way, because they are not derived from sampling theories. To estimate the adequate size of a sample properly, researchers need to determine what level of accuracy is expected of their estimates. That is, how large the standard error is acceptable. Standard error, which is sometimes called a marginal sampling error, is one of the statistical measures that indicate how closely the sample result reflects the true value of a parameter. With this, we have come to the end of our discussion on sampling.